Hello everyone, welcome back to our channel. Now in this video we are going to learn more about AVL tree. First operation that we are going to implement is the insert operation. Okay, and as usual we'll be doing through using recursion. Okay, first we'll create a AVL node and we'll write our insert method. Okay, so let's get into that. So first, as I have already told you, first we'll need a AVL node, right? Let's create that node. Let's really fast. Private class AVL node. Now this is a class. This will have those three variables which we have generally in a node, that is private int value, private AVL node, left child, and private AVL node, right child. Okay, let's create that constructor using which we are going to initialize our node. It will take that value through which we are trying to create the new node. This dot value is equal to value. Perfect. Now that we have our AVL node, we are going to go ahead and create our insert method. That is public void insert and the value that we are trying to insert. Now, as I've already told you, we are going to implement this operation using recursion, right? So let's create that method, insert, which is going to take root node and the value. As you can see, currently we don't have a root node, so let's create that, because without a root node there is no tree. Okay, AVL node, let's call it root. Perfect. Let's create this method then. Okay, so we have our insert method. Now after insertion is done, right, whether it's for the first element or the second or third or fifth element, right, once the insertion is done, after that we are trying to return the root node back. So that's why when we are returning back, right, we need to change the return type to the AVL node. Okay, now let's write our logic, which is if root is equal to null. Okay, we need to create that new node, root is equal to new AVL node with that particular value, and we are going to return it. Okay, that is perfectly fine. Then you need to find the correct place where you're going to insert that value. How do you do that? If value that you're trying to insert is less than root dot value, then what you do, you call the insert method, you're trying to insert it at the left side because it is less than the root value, right, and the value that you're trying to insert. Now every time when you're performing that insertion, right, you are not setting your root correctly. Okay, so you're supposed to set your root right, that is root dot left child is equal to insert this method. If it is not less than, okay, it might be greater, right? In that case, what you're going to do, else root dot right child is equal to insert root dot right child comma value. Okay, now after you're done, inserting all those values whichever we're trying to insert, in the end you're supposed to return the root. So let's do that, return root. And I guess we are done with the implementation. Okay, let's create our main method for the demo. Let's have our AVL tree. I think I have named it alpha tree, alpha AVL. Okay, AVL tree is equal to new AVL tree, that is alpha AVL obviously, AVL tree dot insert 10. Now I'm going to show you one thing. Okay, let's say we are inserting three values, 10, 20, 30, right? We know evil tree is a type of self-balancing tree. Whenever your tree becomes imbalanced, right, at the time of insertion of any value, it is supposed to rebalance it on itself. Okay, currently in the program, as you can see, there is no balancing logic. Okay, let me try running till this point. I think we haven't assigned the root back. Okay, let me do that, then we can debug. That is, root is equal to this, because we need to assign our root correctly. Okay, now let me run. Okay, why the exception? Oh, right, we haven't returned this. We need to return this new node. Yeah, if you don't return this, how it will get assigned? Yeah. Now let's debug finally. Okay, so what do you have? You have evil tree. Now we have added our debug point at line number 36, right? So this insertion should be already done for 10, 20 and 30. Let's see if it is already done or not. So this is your root, which has 10. That is correct. There is no left child because the value that we are trying to insert next is 20. So it should be the right child. As you can see, it is the right child. And again, there is no left child. The value that you're trying to insert is 30, which is the right child of 20, which is correct. And then there is no element, so there is no left or right child. So as you can see, you have 10, then you have 20 as the right child, and then you have 30 as the right child, right? So this tree is actually, the values that you're trying to insert are one after the other. So it is not actually a tree. Okay, this type of tree which has, which is going in one direction, to be specific, this is going in a right direction. Okay, so this type of tree is called right skewed tree. Okay, and again, this is not in a balanced state. So what we need to do now? So first we need to calculate height of each of these nodes so that we can calculate something called as balance factor. Because once you know the balance factor of each node, that particular balance factor will tell us whether the node now that balance factor will tell us whether that particular node is balanced or not. Then we'll understand what are the rotations we need to perform there, and then we perform that rotation. And once we are done performing the rotation, your tree will come back to the balanced state. And that's all we have to do. I hope you got some good explanation on evil tree insert operation. And that's all as part of this video. See you in the next one. May the source be with you.